Today I'm going to be talking about the 1854 Broad Street cholera outbreak. The outbreak happened during the industrialization of Europe in the 18th to 19th centuries, which brought lots of people into the cities. This resulted in overpopulation with houses that had inadequate water transport and inadequate sewer systems for their sizes. This resulted in the spread of diseases such as cholera, influenza, malaria, and many other waterborne diseases. At the time, the miasma theory was largely supported. It basically said that cholera was caused by airborne transmission from dying and decaying matter and transmission of poisonous vapors from bad smell from insanitation. But a fellow English physician called John Snow, as is pictured here, actually found and suggested that cholera was a waterborne disease and was caused by the Broad Street pump for drinking water. He was the founding father of modern epidemiology and investigated the development of cholera in the Soho district in London. City officials didn't agree with John's theory, but they agreed to remove a handle from the pump as a trial, which actually resulted in an almost complete stop of the pandemic in a matter of days. So what causes cholera? Cholera is caused by a microorganism called Vibrio cholera, which is a gram-negative facultative anaerobe that undergoes respiratory and fermentative metabolism. As pictured here, Vibrio cholera is a comma-shaped microorganism that has a single polar flagellum. And due to the short incubation period of cholera, which is actually 2 hours to 5 days, there is an increased likelihood of developing cholera's disease, according to CNN. So the microorganism itself usually resides in water, but can reside in salt water as well, and can easily attach itself to the shells of crabs, shrimp, and other shellfish. It can enter the body of its host when the host consumes undercooked or raw seafood, or in this case of the outbreak, where there was poor sanitation. It uses two virulence factors, the toxin coagulated pilus and cholera toxin, and forms a biofilm that provides the bacteria with protection, giving its ability to live and sustain in a range of environments, and serves as a mean of transportation. The symptoms of cholera, as written down here, include profuse watery diarrhea, vomiting, fast heart rate, loss of skin elasticity, dry mucous membranes, low blood pressure, thirst, muscle cramps, restlessness or irritability, and can even progress into acute renal failure, severe electrolyte imbalances, and coma. And of course, if left untreated, the severe dehydration caused due to the constant loss of fluid loss, it can rapidly lead to shock and death. Cholera is still very much an issue in many third world and developing countries around the world today. In fact, in 2018, there were 499,000, almost 500,000 cases reported in 34 countries with almost 3,000 deaths. Cholera is essentially eradicated in more industrialized nations, but as said earlier, it is more common in areas where there is poor sanitation and in developing countries. So today we have learned a lot more about cholera and we are able to treat it. It's classified as the microorganism, is classified according to the composition of its major surface antigen O into nearly 206 serogroups. However, only O1 and O139 serogroups are known to cause epidemic cholera, which basically means that it affects a group of people in an area. So microbiological analyses and whole genome sequencing have been completed to identify B. cholera strains O1 and O139 and phenotypes and serotypes. There have been 7 major known cholera pandemics. The first 6 were caused by serogroup O1, and the 7th one was caused by a biotype of serogroup O1. In 1885, the first vaccine against cholera was developed, and in the 1980s and 90s, there were oral cholera vaccines that were developed. Today, we have organizations such as the CDC, UNICEF, and WHO who were able to fight against cholera in a well coordinated, multi sectoral approach.